Hey guys, it's Jeff here at Kuroki. Rest assured, the video on precision flat stones is coming. We've just been tied up with customer projects here, and today we have a little bit of deep boring to do, which doesn't happen every day, so I wanted to take a few minutes and grab a little video on it. Don't have time to actually take any footage cutting today. I'll maybe aim for a short, but at least going to give a little overview of the process and talk a bit about these dampened boring bars. So there are a couple other brands. I don't have any experience with them firsthand. We have bars from both Kennametal and Sandvik. The Kennametal is the devibrator tunable bars. You see on the side here, there's a little screw with a negative and a plus, and you use that to adjust the preload on the damper. These essentially have a dense weight of some form, presumably tungsten, but I don't know that for sure. And it's mounted on rubber cushions, and this adjusts the preload on the cushions to help tune out any vibration you're getting. The Sandvik version of these are the Silent Tools bars. We also have one of them. It doesn't have the adjustment, but it still seems to work well. Main reason I'm using the Kennametal bar today is it's a bit longer than the Sandvik. So this is a 2.5-inch diameter bar, and it will comfortably bore almost 30 inches deep, which of course you won't get anywhere close to with a steel bar. You'd be looking at, probably a 4 or 5-inch bar to do that happily in solid steel. Couple things with these. Although you can push them a lot harder, and they're in theory designed to be pushed a lot harder on CNC lathes, I've had good luck running them fairly conservative as far as feeds and speeds. We usually run the lathe about 1 gear slower than we would for typical turning or short boring at this diameter. And we also drop the feed rate down quite a bit. I'm running this at about 3.5 thou per revolution feed rate. And we'll be taking fairly light depth of cuts, probably less than 100 thou off the diameter at max. For the inserts, I've had the best luck with a small nose radius, more of a finishing geometry. Some of the really fine finishing geometries, such as some of the Kennametal inserts, tend to not behave well at deeper cuts. This is a Pramit insert, and we've had really good luck with them in the past. They still leave a finish just as good as some of the other fine finishing inserts, but you can take off a 150, 200 thou cut as long as your feed rates are suited, and they're not designed for it, but they don't seem to mind. Yeah, there's a few other things you got to consider doing real deep boring like this. It is better to run coolant. I won't today, and usually try not to, just by nature of how much of a mess running flood coolant on a manual lathe makes. You also need to watch your work holding. The rigidity of the bar doesn't help you any if your part's flopping around. So we have this one held in a chuck on one end, and then a steady rest with bronze tips for supporting the mouth. I much prefer the bronze tips for these as compared to the roller rests. Unless you have a really heavy roller rest with proper cam follower rollers, they just don't behave as well as bronze tips. As far as lubricating these ones for lighter duty work, if you just gotta drill a hole in something like center drill a shaft or do a little quick job, you can get away with just using either a regular grease or a whey oil. For things like this, we're going to be running an extended period of time. You need something with a fair bit more extreme pressure. I haven't used it myself, although I know a lot of people have good luck with moly-based lubricants, such as a moly coat. We've used either this stuff, see if I can get this in focus, called Instead Lead, which is essentially a synthetic lead-free replacement for the old white lead paste. The other product that works really well, although I don't have a tube here to show you, is SimCool Center Saver. It's kind of a pink slime put out by the same SimCool that makes all the synthetic cutting fluids and the like. It works really well also. I just have a can of this reusing up currently before we place another order. The thing with these tunable bars is you have to have them set right. What I found generally works well is to start with the screw somewhere roughly in the middle of the range, and most of the time that seems to work fine. If it is chattering, turn it half a turn one way and see what happens. If it gets better, try turning it a bit more. If it gets worse, turn it back and go a bit the other way. And it's there may be a more scientific way to set these, but this works and it's one less thing to keep track of. So you'll just take a couple of light cuts near the mouth to get it behaving right, because your stick out from your tool post to your cutter is always going to stay the same. So it's going to cut the same right at the mouth of the tube as it does all the way at the end. So just get it set up at the mouth, and that way if you do get any chatter that you have to take out, you can go in there with a stubby little boring bar and clean it up, and you aren't fighting something all the way down at the bottom of your bore. So you need to make sure you're cutting well before you go at it. But overall, these do a really remarkably nice job. This being a hydraulic cylinder barrel does still need to be honed after, but you really don't have to take much out. As long as your lathe is cutting straight and you don't have a taper to remove, you can usually start with a 240 grit stone and just hit it with a 240 and a 400 rather than starting at a coarse stone and having to work your way through and leaving 15, 20 thou to clean up. I've gotten away with, on shorter bores than this, as little as 2 to 3 thou of honing allowance, and still been able to have them clean up 100% with a nice fine finish. Anyways, I hope some of you found that interesting, and we will be hoping to keep up a little bit more regular upload schedule going forward.